Okay, good evening, everybody. It's nice to be here with you all. Just like I've been introduced, I'm Bilikisu W Aderinto. Okay, so I'm a business data analyst with Business Data Lab. You can find more information about me on LinkedIn and as well as my social media handle. That's the Twitter. Okay, today we're going to be having an introduction to Tidymodels. So we're going to basically go through a little bit of theory, but the hands-on will help us to get better understanding of the model. So I'm a user, so I'll try my best to do justice to the introductory aspect of the webinar. So Tidymodels, just as it's been described here on the web, it's a framework and it's a collection of packages for modeling and machine learning using Tidyverse principles. So if you're familiar with Tidyverse, you'll know the ease that comes with it in working with data, especially data frames, and host of other packages that you have there. So this just mimicking the ease that comes with Tidyverse. So Tidymodel is not actually performing the statistical models that we're looking at, but it's providing a framework, like a platform where you can achieve all this through data preprocessing and the fitting of your models. So we're not going to go so much into machine learning as well. So, but the goal of machine learning and the reason why we have Tidymodels is to build models that generate accurate predictions for future yet to be seen data. The accuracy here, we're not looking at the perfect accuracy for our predictions, but we're looking at something close to what is acceptable for future use. So, and where does Tidymodels fit in the framework of machine learning using the Tidyverse principle? It fits into the model aspect, as you can see on the screen here. So the importation, tidying, transformation of your data, visualization goes into the Tidyverse. That's where you achieve that. While Tidymodels helps you with your modeling, while the others are for sharing the output from your model. So today we're going to be looking basically at some of the packages. As you can see, what we're having here, we're having sub packages within the Tidymodels. We're having the R sample, parsnip, recipes, tune, then the yardstick. We're actually going to be focusing more in understanding the preprocesses that you can achieve with Tidymodels, how you can train your model, then validation. Want to validate our model. We're also going to look at some tuning, but we're not going to go deep into that. So when you're working with Tidymodels, these are some of the packages that you can have access to working with the package. So we have the Broom package that helps you to bring out the output of your models, that's your trained models, in a tidy format. Then we have the dials, dplyr that you have in Tidyverse. But the core aspect that we're looking at here are those on my right, that the recipes, the R sample, the tune, the workflows, the yardstick. Then we have the parsnip here on the left. So before we go ahead, we're going to be explaining most of these packages using the demo that I have on ground. We're going to be working with a bank's marketing data that was generated from online, was gotten from online. So we're going to kind of predict if a customer is going to subscribe to one of our campaigns or not. So through this demo, you're going to understand all the most of the packages that are within the Tidymodels. So I would like to go to my R Studio, although I'm still running here. So I'll share my screen now.
Make it full screen, please.
Okay, I'll do that.
Thank you.
So I hope you can see my screen, my R
Yes.
Studio screen.
Yes, it's okay.
Okay. Okay, so here we're going to be looking at the data sets that is going to be provided for us. As you can see on my screen here, I've run the Tidymodels package, and you can see the various packages that we're going to be talking about, the recipes, R samples, and all this stuff. So I'm going to bring in the data. I'm going to show you the data set that we're going to be working with. So this is the data set that we're going to be working with. While going through the demo, I'll explain each of the packages that I'm going to be using while referring to the online website for Tidymodels. So here we have the data set. We have there's 21 columns here, but the actual target variable that we're looking at is the Y variable that tells us if the customer or the client subscribes or not. So the first thing that we're going to be looking at is how do we, which of these packages do we need to bring in first? We need to examine our data first because there are so many opportunities that comes with using Tidymodels. When you're looking at the data set that you're working with, if you're having some issues with the balance of your data, we need to first of all tackle that. So I'm not going to look at the aspect that I've done using tidyverse, that's transforming my data. So this is not what we're particular about in this program, but I would like you to look at the visualizations here. Here we're looking at the spread of the customers accepting the campaign that they offer, the campaign that has been given to them or not. So here, if we look at the plot here, we can see there's imbalance in the data that we're having. We have more of data on clients that says no compared to what we're having with those who said yes. So it's kind of going to look kind of a biased prediction somehow. So we'll look at how do we balance up the data that we're going to be using to fit our model as well as for the testing. So here, let me show you other visualizations here. If we're looking at the campaign, each of the campaigns that were part of the data that we're having here, the data actually is not balanced. So we have to go into, the first thing is, let's split the data. In machine learning, let me go back to my slide here. In machine learning, you would have to split your data first. That's the first thing that you need to do. We need to have the data that we're going to use for training, while we have the other one as the one that we're going to use for validation of the model that we've generated. So that will be the testing data. So in Tidymodels, the package that we're going to be using for this is the R sample package. So if you look at we'll go online. Let me open so this is the main website for Tidymodels package. So if we look at the R sample, The R sample package helps us to split our data into the training data set and as well as the testing data set. So you can read more on this. It gives you a better understanding of what you can do with the package. So I'll go back to the R Studio. So now I want to, because the main focus here is to predict if a customer is going to subscribe to the campaign or not, we need to split the data referencing this particular variable, that's the Y column. So we're going to do the achieve the splitting using that as a reference. So that's what is going to be passed into the function. This function is available in the R sample package. That's the function initial underscore split. This function helps us to split the data. Then we have a split data, the object that is going to be returned to us, and from this object we're going to be able to extract our training as well as our testing data. So if we run this line of code here, we're going to get a split object which we can now extract the training data set from it, as well as the testing. Also, you can also decide, okay, if I don't want to reference that's my output, that's the prediction, that the Y column, I don't want to use that as my reference for splitting the data. We can now use the proportion argument. So we might want to say, let the training data set be 70% of my total data set, while the testing should be 30. And it depends on your choice. You can make it 80, 90, it depends on what you're actually looking at. So I'll comment out this. So my split was done using the strata as equal to Y. So this helps us to kind of achieve our splitting in a way that is kind of in a tidy way. That's what I would say. I'll use that term also. So the split object that was generated, when you run this line of code, we will get this output. So now we're having the analysis, that the analysis is the training data set that we're going to be having. That's 24,000 plus, while the testing data is going to be the one here. That's 8,000 plus. So the total, the last value that is being shown here is the total data that we're actually splitting. So the next thing is we want to extract the training and testing data set. So the next thing that we want to, if you don't have any clue about where any of these functions are coming in, you can go to your console, put the question mark, and just put the name of the function there. So the first function that we're going to use to extract the training data is the training function. So this function will pass in the split object into it. So that will be the argument that is going to, the value for the argument that is going to take. So this helps us to extract the training data set that corresponds to this value, the number of rows here. So going forward, we can examine the counts. How is the spread still available within our training data? So you can see we still don't have a balanced data here that we're working with. We have more of the no and less. So the value for the number of observations for the customers that says yes is kind of so low compared to what we have for those that said no. So we're also going to extract out the testing data set. So we use the function testing here. So the same parameter that we're going to pass in is the split object, that's the bank marketing split. So this helps to bring out the testing data that we're going to be using. So we're looking at this as well. We actually don't have a balanced data here, so it's imbalanced. So now going forward, all what we've been talking about as imbalance, the data is not balanced and all this stuff, we can now go forward, going to the recipes package. The recipes package helps us to achieve the pre-processing that is needed on our data. There are so many pre-processes that we do to help the data to be in a state that will give us a better model that can help us in future to predict the values that we can use for future data set that would be passed in. So let me just because I restarted my system, so I don't have much of my R Markdown run. So I will be doing that while I'm going through this. So let me look. Okay, so I'll go back to the recipes package now. Okay, here we are. So some of the preprocesses that we can do are, if we're having numeric values, we might want to look at the correlation. So for us to make use of the recipes package, there are some functions that comes with it. If we go, let's go back to, I'll take you back to the website. So if we are looking at which function do we need for our preprocesses, you might want to look at the website here, or you type the step, that is the function, most of the functions that will be helping you starts with step. But let's go to the website here. If you're looking for, maybe you have a task you want to do, maybe a preprocessing that you want to do, you might want to come here to make life easier for you as a beginner. Let's search through the recipes package. So if I click on this link, it's going to take us to a page where you can search and look, okay, maybe I want to perform kind of normalization on the data. I can type in here and you can see it's now bringing a search result for me. Now, if I want to normalize my data, I can use either of these functions. The step underscore normalize helps me to scale as well as center the numeric values that I'm having. So I hope you would understand the scaling, and that's you're having the standard deviations as well as your mean. You're looking at, okay, I need to center or the scale down my data to be in the same scale. So all this out of scope here, but for us to normalize our data, we have to use this function, and it helps us to achieve this in the easiest way. You don't have to know what's going on in the background. So if you click on this function, it gives you more explanations on what you can do with it. So clicking on the function here, it says creates a specification of a recipe step that will normalize numeric data to have a standard deviation of 0 and a mean of standard deviation of 1 and a mean of 0. You might want to read more about the effect of scaling and centering your data. So, but this helps us to achieve this. So it's so easy when you want to work with the recipe package. You might just, let me kind of type something down here. Step. Immediately you type step, you put the underscore. You have a pop-up that helps you to look through and see the various functions that you can use. We have the bin to factor. You can also do mutation, that is, you can decide, okay, I don't want to scale and create a center of my numeric data. You might just want, okay, let me just scale my data. That's the numeric values that I'm having. So all these options are here, the correlation, the counts, so many. You can also create dummy variables on your denominator, that's the categorical variables that you're having in your data set. So all these functions are available. You just need to explore and make use of the website. It makes life easier by you going there, you search, and you'll be able to get what you're looking for. So now going forward, my recipe, it's just like the name suggests, recipe. You're actually kind of bringing up an object that helps you to itemize or bring together all the steps that you need to put your data in the right shape or in the right format for your model, for you to train your model with. So here I'm looking at, okay, my data set. I want to look for those variables that are numeric, that are kind of correlated to. So I want to kind of deal with that using this function. So that helps me to achieve that. Then the normalization, then creating dummy variables on all my categorical values. But I'm exempt. I'm taking out this. Here you can, for all the functions, you can decide to just specify a variable. You don't have to kind of group all of them together, because all these functions, the sub functions that kind of like values. Sorry. Okay. We'll answer the questions later. So the dummy variables, the step underscore dummy helps you to create dummy variables. You'll look at the output. Take a look at the output as we go on. So, but recipe is more or less like the steps you need to do to take to achieve a certain goal in your pre-processing steps. So maybe you want to cook rice or something. There are steps that you need to follow to achieve the final result. So this is actually what the recipe is doing. So it's not giving you your data, but there's no data that has been used here. We're just actually saying these are the steps that I'm going to perform on this data that was first of all placed here, that is not like a value that is passed to the recipe. But for us to get out the actual data that has been pre-processed, we need to use another function. So if we look at this, if we look at the bank marketing recipe, this is the output that you will get. So it's going to give you a kind of a summary of what I would achieve with this recipe that I've kind of defined here. So what I'm going to achieve is correlation filter on all numeric values. Then I'm centering and scaling down all numeric values. Then dummy variables are going to be created on all nominal values here. So with the exception of our output. So that's the y variable. So then also there's something that I omitted here. The imbalance data that we're talking about at the beginning, this step underscore smooth helps us to achieve that. And I'll show you what that does later. We're so close now. So this helps us to balance all the data. So we have the same equal amount of those clients that said no, as well as those clients that said yes. So instead of working with a partial data that we're having at the beginning, we're going to have equal proportion of all the data now. So moving on, in order for us to now get the processed or prepped data, we need to use another function called prep. That now we're preparing our data based on the recipe that we defined earlier. So we're going to apply the recipe, use the recipe to prepare our data. So using this function, where you pass it using the pipe function, we're going to get out a prepared trained data set that we're going to use on our model, in fitting our model. So here, where we use the prep data, we're going to get this output. Then there's a new update on the recipes package. There's another function that I'm not using here. That's called the juice function. This is now kind of taken out, is now not used anymore, because it's supposed to kind of take out that processed data. So, and it's kind of similar to what the bake function does. So it's going to use the prepped trained data to generate a data based on the trained data set or another data set. So you can use it, you can use the bake function to generate a processed data set based on the recipe. So you just need to, what you just need to do is just pass that data into this as a value to this argument here. That's new underscore data. So, but here we're using null because we want it to return back to us the train data that was used for the preparation here. So that's the data that we started with from within the recipe. So that's the bank marketing underscore train. So we're actually still working with the train data set. So we'll still see how we're using this recipe as well as the bake function on our testing data set later on. So if we take a look at the output now, you'll see that all our data has been transformed. All of them has been transformed based on the recipe that we provided, that we defined. So all of them has been, they've been transformed. So we now, instead of 21 columns, we're having 52 columns. You know, we asked it to create dummy variables for us. So this is the output now that we're having. So you can see all of the dummy variables on all the nominal values, that the day of the week, the months, and all this stuff. So we have more columns now that we're working with. So now, based on the imbalance of nature of our data, we use this step, that's step underscore smooth function. So this helps us to get a balanced data set. So when you look at the prepped data that we generated from the bake function, if we look at the count, you'll see now that we have the same equal number of those clients that said no, as well as those that said yes. So this is good for us to work with. So one thing I want to chip in here, there are some data sets that you might decide that, okay, I don't want to prep, I don't want to do any processing or anything based on the type of model that you're using. So we'll get to look at that in the second part of the demo. So I will showcase that. So now going forward, now we have our data in a state that we can use. We can now go forward to looking at getting or selecting our model. So when you want to look at selecting your model, you'll be using the parsnip packages. The parsnip package, I mean, so it's just one package, sorry. So we'll be looking at using the parsnip package. So I want to kind of run this. Let's do the last one. Okay. So that I wouldn't take much of the time, I want to run some lines of code here. Okay, I think this should not take more time. Okay, so let me take us to the web, the Tidymodel website again. So for you, if you don't have a clue of what the actual maybe model that you want to use, we might want to go back to the Tidymodel website This is easier for you. Just don't go looking around, shopping around for models, but you can come to the the website here and just type in, okay, what do I want to, which type of model am I looking at? And I said, okay, I want to look at the linear model. So if you type in your linear model, or you know the name of maybe the algorithm or anything that you want to use, Parsnip actually helps you create like a framework for you to assess those the model, the type of model or package that you want to use. It's like a framework or maybe a gateway for you to connect with those packages. So here, if we look at the linear model, so we have two here. So we have the linear regression, which just for regression analysis. That's for this. Then we have the other one for classification. But today we're looking at binary classification. We're looking at maybe want to use the logistic regression. So if I type in logistic regression model now, you can see it's bringing it up. So, but today within the demo, I'm using the random forest models. So here we can use the random forest models for both classification and regression. So, and here you can see there's different information that you have here. We have the title, we have the model type, that's the random forest, that's the name of the engine that we'll be using. Then the package, and the package here, that's the Parsnip package. So it's the framework is creating like a gateway means for you to access those model. Then what are we using it for? It's for a classification model or regression. So actually in this sense, we're using classification. So random forest, or we can use the engine would be either you want to use random forest or Ranger or Spark. So, but today I'm going to compare the random forest as well as the Ranger for the engine that we're going to be using. So let me give a little breakdown. I'll go back to my slide. Sorry. So going back to my slide here. So we've dealt with this the recipe package. So here, for you to use the Parsnip package, there are 3 steps that you need to go through. You need to specify the definition for your model. So the first one will be, I'm going to select a model. Then 2, we need to set the engine that you're going to be using, random forest or Ranger, Spark, whatever, whichever one that is related to the model that you're using. So then you set the mode, which could be optional here. So this is kind of an example here. We're looking at the Ranger specification. So the first one here is the model, just like it's been rightly stated here. We look at the model, then the mode. You know, for the random forest model, we can either use it for classification or regression. So here we're specifying the mode as classification. So you need to be specific on this. Then the engine that we're going to use, we're going to say, okay, I want to use the Ranger or I want to use the random forest. So whichever one you want to use, you need to specify there. Or there are some models that it's optional for you to specify that. So I'll take you. So I know there's some. Okay, so we'll take questions later. So let me go back to my R studio. Okay. Okay, so now for the first one, I'm using the Ranger as the engine, the engine that I'm specifying here. So here I'm actually going directly into using that's the model, that's random forest. So I'm going to use the other side in the second part of this program. So here there are some parameters or arguments that you might want to put in, but because of time, we're not going to go into that. But this is the mode now, is the classification model that we're looking at. So, and the engine is going to be Ranger. Here, I'm actually going forward to kind of, I'm fitting the model immediately now so that things will be kind of fast. So if I run this, actually I've run this, so I wouldn't want to take the time because it's going to take some time first. So if you're adding the fit function, this is helping you to fit your train model to the model that you've defined. So I'm fitting in the train model that we've prepared, that has gone through the pre-processing steps and all this stuff. So we'll now fitting to look at how what's going to be the output from our model. I'll try my best to make it simple, but here we're looking at, let's first of all use this model on the trained or prepared trained data set before we now test it with our testing data set. So that's what we're doing here. So we need to feed the model on the prepared training data set first before we now say, let's test it with our testing data. So here we've done that with both using the engine Ranger as well as the random forest. So now let's look at the predictions that, okay, now so from what I said earlier, we've fitted our data, the trained data, to the model that we're using. Now we need to prepare the testing data as well. So this is how so I'm not going back to putting the testing data into the recipe because I've already defined my recipe. So I'm just going to pass that into the bake function, but I'm going to prepare it with the trained data sets. So that's why I'm passing that in here. So, but the new data that I'm using the recipe on is going to be the testing data set that was generated. So that's why new data here is not null now, because we're not referring to the trained data set, but we're now referring to the testing data set. So the recipe is going to be used on our testing data set, although we actually prepare it using the training data set. So the outcome is this. So you can see the same output is being generated here. So all the steps have been applied to the testing data set as well. So now let's go look at predicting using the models. So here we would try and do that. So this is the output. If you run the line, because I'm running some codes behind here. So if we run this line of code, the predict function is actually from the tune package. So the tune package helps us to bring out the results of what our model can do for us. Maybe that's predicting what we can use in the future or make decisions on. That's the main objective of our machine learning. So that's why we need to create a model that we can use in future, with future data set that we don't know. So we're actually predicting here. So the outcome of this will now be compared to what we had on ground before in our training data set, as well as the testing data set. So now we want to predict using, we've done our prediction using the trained data set. Now we want to, that's the fitting with the trained data set. Now we're predicting based on the testing data set. So now let's look at how well did the prediction come out. So here we'll look at combining the output, that's a single column that is being returned here. We'll combine it, that we'll bind using this function that's from the tidyverse package. We'll use this to combine the value that we had in our testing data set. So here we need to compare. We are going to compare what we are having compared to what we are predicting. So if you look at the little data that has been displayed here, you can say from the last value that is here, the prediction was actually no, but the actual value was yes. So your model cannot, it should be accurate, but can't be 100% accurate. We all know that. So now let's look at predicting using the second, then that's the random forest. So this has been done here. So I'll move forward and show what we have here. So this is the output now, comparing by combining the two columns from what we predicted as well as what we have in the test data set. So moving on, we want to look at the metrics that we can generate from this package and from the whole output. So here the validation comes within using the Jastic package that's within that's the Tidymodels package. So here we want to bring out for the Ranger engine that we used, what is the metrics that comes with it using the using the testing data set. So here we can see for the accuracy we're having almost 90%. So then the the cap value is 0.5. So I think it's a good model that we can say here. It's actually did well. For the random forest, almost the same thing. So we have almost the same value, just the difference is within the cap value here. All these metrics can be read, you can do some research, more researches, and to get more information about it. So this is what we're having here. But I'll quickly go through. I'm not going to run the script. So here, there's another way you can use the Tidymodels. That I said at the beginning, you don't have to do the preparation. You don't have to. There are some models that don't need, actually, like random forest. You might not need to do much of pre-processing there. You might not need it. So if you want to learn more about that, you might want to go to the Tidy Modeling with her website. There you'll learn more about, there are some package or models that you might not need to do much of pre-processing. So moving forward, let me show you what I did here. So also here, there's a difference between what I did earlier and what I'm doing here. We have a large data set that we're working with here. You might want to say, okay, let me kind of split my data into different samples. Maybe you want to do cross-validation. You might decide to create some folds that you want to work with. Here, I'm actually looking at creating the samples, breaking down my data set into smaller chunks that I can now use my model to train with first, before now using the testing data, because the testing data sets, like the expert will say, is very precious. You need to keep that aside, but you can split your training data set into kind of mini training testing data sets. So that's where the bootstrap, the cross-validation comes in, that for creating samples based on cross-validation when we're using vfolds function, but I'm not using that here. So I'm using the bootstrap here. So the bootstrap function helps you to create different samples. So here we have 25 rows of samples that you can work with. First of all, use your model. Train your model with all these samples before you will now use it on the testing data set. So here I use the same model as well as the same engine and mode. So to go through all the same steps, but I actually did not, I'm not using, you can see I'm not creating any recipe here, but I want to add a formula. I'm adding a formula through a workflow that I'm creating here. The workflow helps you to kind of create a well-defined route for you to create your model. So the workflow now here, we can add our formula or the recipe and add our model that we want to use. Here, the first step you need to do is to start with the model, the workflow. Then I'm adding the formula. So that exempts me going through the pre-processing steps. So I'm not doing any pre-processing or anything here, nothing. So I'm just specifying, okay, I'm using this as my predictor, but the other columns should be the variables that I'm going to use for predictions. So here we'll move on. So you can see the output here for the workflow, there's no model that was specified here. So the next step would be that you add the model. So I'm adding the model here as well as fitting. Now here we're going to be fitting all the samples. All the samples are going to be fitted onto the model as well as the work within the workflow. So the output is going to be something like this. So everything is going to go through each of the samples that were created using the bootstrap function. So then there's going to be the metrics on them, then the predictions for each of the samples. So moving on, the same thing we did with, I'm using for the random forest as well. So now evaluating the various models. So here we have the metrics. We can use the function collect metrics from the tune package. We're collecting bringing out the various metrics that we're looking at. So here we have the accuracy as well as the area under the curve. So the values, they are almost the same thing as pre-processing. So you can see that sometimes the pre-processing steps might not be needed somehow. So then for the ranges, the same thing here. So if we compare the two, we can see that using the ranges engine kind of work a little bit of different. That's just it. If we look at the two, so also you can using the tune package as well, you can bring out the confusion matrix table using this function. Sorry, I'm kind of fast, but we can't do justice to the whole package. It's just an introduction. So the confusion matrix table can be generated here. If you look at our prediction, this is our prediction, then this will be the truth. So for the first row tells us that, okay, this is the ones that were correctly predicted. Then the next line says this was our prediction, then the truth was actually yes. So these were not correctly predicted. So for the yeses, this was not correctly predicted. So the last one is the yes were correctly predicted on this aspect. So that's that. So the tidy model is actually very powerful. It's more or less like your toolbox when you're looking at machine learning in R. So there's other packages that might want to use, but actually it helps you so much with all the sub packages that are within it. So the confusion matrix here for all the samples are the same thing for the random forest. So the same thing goes here. It's actually performed well. So for all the various samples that we created, you get the output by collecting the predictions. That's using this function again on the results, the entire result that was generated. So if you look at the number of rows here, you can say it's kind of multiple. So that's 227 rows now compared to like I think 54 or so thousands of rows that we had before. So, but with all what we have, we can group all these predictions. We can group the results into each of the samples that we had. So we can group them and create plots. You can either use, if we want to create the generate the plots, that's the area under the curve. That's, we'll look at the, you can use this function that's auto plots, still running there. So you can use the auto plot to generate the plots for you, or you skip that and use your normal ggplots if you want to have much more power on the plot that is going to be generated. So this is the output of what we're having here. So we look at the sensitivity as well as the specificity here. So moving forward, so here the reason why I have two scripts here is just to tell you that you might want to skip some steps. It's just a mean, the Tidymodels is a means for you to have ease working as an R user, working on creating machine learning models. So different, okay, for this aspect, we can fit, we can also collect metrics on the final fitting, then we look at the accuracies and the return, the area under the curve. All these metrics are all functions that you can get within the Tidymodels package. So I wouldn't want to take much over that. I don't know if I have time to explain some things, but I think I can kind of deal with that in the question and answer section.
As in fact, thank you. And as you like, if you want to add something, it's okay about the time.
Okay, I still have some time.
Yes,
Okay, okay,
it's
good.
okay.
Okay. So yeah, from what we've seen here, we're fitting the final fitting on the testing data that we're using. Here we only fitted on the training data set. That's the samples that we have, because all the samples were created using the train sample. Let me show you here. Okay, if you look at this, we have all the samples created only on the training data set. So that's what we've done so far up to here. So the final fitting is going to be based on the testing data set. Okay. So here we can add the model that we want to use. Based on what we've seen so far, I think the Ranger model is working better, a little bit better. So that's why we're using that as a reference here. So here I'm not specifying the testing data set per se, but I'm looking at, we want to do the fitting referencing the training data set, but we're actually fitting on the testing data set. So it's not that we're using the two. No, we're going to be fitting on the testing data set here, while we're using the specification for the model as the Ranger model through the workflow here. So then the final result is here. So, but we can collect out the metrics here. So this is the final output. So it's going to be like a split, but you can get out the metrics here that we want to use. So the metrics almost the same thing compared to when we did the pre-processing. So here is much more better. If we look back, so from the first script that I had, we look at the model was actually able to do more of the work by itself. You can see it's 0.90 here, while here we're having 0.91. Then for the area under the curve, we have 9.4. So it's kind of better sometimes, but you need to just know, you need to get to know your model much before you specify. You need to know which model would I be using, which processing steps do I need to take using the recipe package or not, or maybe I need to skip this. It's going to be okay working with it on its own. So then we can also collect the confusion matrix here. So if we look at what we've generated, actually, it actually did well. You can see the output, it's not on the training data set. It's actually on the testing that you can see the number here. So that I think that's where I would like to stop here. So, and I will answer the questions that I can take. Thank you.
Thank you.
Thank you so much for this great workshop. So personally, I learned a lot from you today.
Thank you.
So I really like how you explain very well, and so you get a clear understanding of the different functions included in the Tidyverse package. Thank you so much.
Thank you.
Thank you. I think we have some questions.
Okay, so you have here questions from Mohammed. He was asking, so in Tidymodels packages, which is the dedicated tools to update the missing values? So he found, sorry, on the website that you can input using bucket trees and Kai nearest neighbors. So did you have an idea about?
Okay. Well, the answer I would want to give here is it depends on your data. I wouldn't want to say specifically that, okay, you said I can find on the web, you can impute using backtrace and k-net. No, you can also impute using mean. Let me go back to the R Studio and show you some of these tests that, okay, actually, let's go to the website. Let me take you to the website. So as a beginner, even a professional, you need to, you can refer to the website anytime. So it helps, makes life easy. So let me show you. We can go back there. This is one way, or you go through the R Studio and just type step. Let's go there. So I'll type missing. Okay. So missing, you can see, I hope you can see my screen.
Yes.
Yes.
Oh, okay, good. So here I've typed missing. So you can see, you can check for missing values here, or you type impute in. Okay, this is okay. Let me take you to it's not helping here, missing value. Okay. So here you remove observations with missing values, but there are other methods that you can use. I'll take you to our studio. I think that will help better. So I will share my screen, take you back to our studio, and you can see various steps. If you look at my console, just look on the right side here. Okay, I'll just type step underscore. Okay, good. Okay, so if you look through gently, so we'll see, can see here, the first one that you see is KNN input. That's K nearest neighbor. You can do your imputation using the K nearest neighbor here. Then if you go down, look at the step mean input or using the median mode. So these 4 functions helps you to achieve imputation on your missing values. It now depends on your data. You have to, there's different steps that you need to go through before you decide on which one do I want to use. So you need to look, first of all, look at your statistical mode and interpretation of your data before you decide, okay, I want to use the mean as the value that I want to replace my missing values with, or maybe it's a kind of a nominal data or categorical data. Okay, I want to use the mode or the median. It depends on the situation in which you find yourself. Which data, what's my data saying? So I can't really say that, okay, this is what you should use, but it depends on what you want to do. I hope I answer your question.
Yes, it's great.
Okay, thank you.
Next question.
So Janelle is wondering, so she doesn't understand why you made the dummy variables, but she said great talk. Thank you, Janelle.
Oh, okay. Okay. That's another topic, but I'll try and explain to you. Okay. So dummy variables, we usually create dummy because when you're working with machine learning, let me say it in a layman's term as much as because this is an introductory class. We're creating dummy variables because we kind of want to make life easy for the machine learning, for the machine to learn. Machines work better with numbers. That is so the dummy variables are actually, you are taking your kind of district values, you are now creating numerical equivalents, kind of that's what it kind of that's the what I can really explain. So with this you can see the output that we add after the pre-processing. Let me show you the month, day of the week, let me just take you there. You'll see what I'm talking about. So it's actually part of the pre-processing steps that we need to do. We don't want to pass our categorical variables just like that to the model to learn with. I'll show you now. Okay, so sorry. Let me take you to the first script. That is where you'll see. Okay, here. So here, the dummy variables, they are created by kind of, if you're looking at, okay, the day of the week, the month, I think which other aspect, the employed, all these areas, they are kind of, they were like text values before. If you look at my screen, they were actually text values. That's the education, marital status. When you create the dummy variables, you are actually linking, creating a relationship, but using numerical values now. A relationship between all the categorical values. All the categorical values that you have in here, and you're creating numerical equivalents based on those relationships. I will take you there again. So now you can see month is being splitted based on their values, month underscore June, month underscore March, May, November. All these are kind of the values that you get when you create a dummy variables. I don't know how to explain much more. So you can see the dummy variables are linking the values under each of the and the categorical values, as well as the relationship between other categorical values there. So I think that's what I can say now. You got the output here. You can see we didn't actually ask the recipe definition to create dummy values on it. It's still there because it's going to affect what we're actually telling the model to do. I hope I've tried to explain better.
All
But you
right.
can read it up. Read it up.
All right, that's perfect. Back to you, Monet, for more questions, please. Monet, can you hear me?
Yes, sorry, I was unmute. So thank you, Kauthar. So here, Aurora is asking, after saying thank you very much, so is it possible to access this script from your GitHub? So did you share your work on GitHub?
Okay, I'm going to share it on GitHub. Actually, it's not on GitHub yet. I'll share it. I don't know if you can get it across to all those who are registered, but I'll share it.
Okay, thank you so much.
Thank you. It will be great.
Yes.
Okay. I think
So
there's another question.
Yes, Shamsuddin is asking if he is coming from Python ecosystem, and he is asking if Tidymodels is synonyms of sklearn.
I wouldn't say, I don't know how to, but I wouldn't say it's synonymous to sklearn. No. Tidymodel is kind of no, it's not synonymous to sklearn. I know a little bit about it more, but I'm an R user, but I know a little bit about sklearn, but no, it's not synonymous. There are so many differences there that you wouldn't know. That's just what I would say.
I think they have, because I'm using sklearn with Tidymodels. I think they have some similarities about when you do the pre-processing and the pipes, all these things, and in the models also, and how you can do the confusion matrix, something like that. They have some similarities, I think.
Yeah, now we're talking the synonymous aspect. That's what I'm saying.
Yeah.
So I wouldn't want to go so much. So, okay, sklearn and Tidymodels. Okay.
So you have here Muhammad Ali, who's looking for recommendation for beginners. Is it better to use Carrot package or Tidymodels packages under the programming language R for beginners?
From what I've heard so much from Max, the creator of Carrot, I would suggest you start with Tidymodels. Actually, Carrot is still there, but more work is on the Tidymodels now. So Carrot is not scrapped, but more work is on Tidymodels. That's why I would say it's better to start with, as a beginner, it's better to start with Tidymodels. That's what I would suggest.
Thank you. So I think you are done with the questions. I think there is no more questions. Thank you again, and thank you so much for all the participants for your attention and for joining us today, and also for getting in touch with us today. So stay tuned to our upcoming events. It will be possible later to review this workshop session, as we will aim to share that on our YouTube channel as always. So let me just quickly share with you the link of our YouTube channel, so maybe you may review the previous workshops that we have organized. Thank you all.
Thank you so much, speaker.
You are welcome, Ayman.
Thank you.
Thank you.
So good evening.
Good
Bye,
evening.
goodbye.
Bye. Thank you
Bye.
again, Bilikisu, for accepting our invitation. Thank you.
Yes, it was so great.
Thank you all.
Bye.
Thank you.
Thank you so much.
Yeah.
Okay.
Thank you so much for our speaker. Goodbye.
Thank you. Goodbye.
Goodbye. Thank you.
You are welcome, Rifqa.